Ja, goddagens. Vad tog andra halvan vägen? De försvann. Wow, ja just det var från er. Han var bra. Hej, välkomna till lite föreläsning i 527an. Nu ska vi gå över och I'll switch to English since you're we will transition to the next part of the course, the REST API design or API design in general part of the course. This is also connected to the second assignment, that is basically creating a RESTful interface. And the details on that one I think is updated and ready, so you should be able to start working on that one whenever you like. However, focus maybe on the writing assignment, the first one first, so you don't miss the deadline on that one. I think that's the smart thing to do. And this part of the course has been Jon's Hegerus part before. When he quit, we started looking around, and I found that, oh my God, Francis has done a lot of stuff in this area actually. So this is a like perfect match, I think, for this part. I will also watch the lectures, and I know Jon's take on stuff, and it will be really interesting to see if there is a difference in opinion, because this is, as I think Francis will tell you, is like a part where you can have different opinions, and there is maybe not right and wrong, but there are a lot of like ways of doing it, and probably some ways are better than others. So I will leave the mic to Dr. Francis Palma. I don't think you met. No, you have had the other class, the utveckling och drift av mjukvarusystem, or the operations students and the engineering students. So I will let you introduce yourself and the subject, and I will actually go to my office. So
yeah, thank you.
Thank you.
So maybe you can also move to closer if you want, so that we can see each other very closely. Else since we don't have many students. So some people are following from Slack also, right?
Yeah.
Okay. I don't know how many of them, but hopefully we can have a nice conversation. So good afternoon, everyone, and welcome to this part of the course that is basically on web APIs. And in particular, we will talk about some design rules of APIs. So have any one of you developed before REST APIs or written APIs?
A little bit.
Little bit? Okay. So then maybe you didn't write at all?
No.
Okay, then maybe it will be a good start for you.
Yep.
And maybe there will be some good lessons also for those who already wrote some APIs. So I am, as you can see, the senior lecturer in computer science, and this lecture is particularly interested for me because all my previous research, or most of my previous research, are based on REST APIs, and to analyze them to see how well designed or how developers care about good quality design. So I will show you basically many rules today, and by rules what I mean, you have to strictly follow them if you claim your REST APIs, your APIs to be REST, or if you are saying that my APIs is RESTful. So those rules are obvious, and in your assignment you are also expected to apply those rules in particular. So your assignment will be evaluated based on how much you could understand from this course and how much rules you applied in your design or in your implementation. So for this part of the course, I mainly looked at two different books. I don't know if you know any of the books. Okay, so those are pretty well known and simply written. Simply written, I mean they are easy to understand. And in particular, I focused on this book, REST API, but those books are pretty much similar. So that book mostly focused on the restfulness of web APIs, but this book mostly focus on the design of APIs itself. So it doesn't put more attention on restfulness, but it ensured that APIs are designed in a good quality in terms of design practices. So we will have two parts for this lecture, or so for this part of the course. In the first part, that is today, we will talk some brief introduction on REST. So you know some REST about something about REST. Any background on the REST? Okay, so maybe it will be easier for you to follow. Then we will also talk about the identifier design and interaction design, because these are the two most common concept in REST. And the lecture I think on Wednesday, right? So on the next lecture, we will talk more about metadata design and representation design, and what are the various client concern in terms of REST design. So from this outline, as you can see, we will talk more about identifier, we will talk more about interaction, we will talk more about representation, and also metadata, and finally client. So these 5 are basic building blocks, or most important building block for REST APIs, and you will see eventually why. So moving to the first part of the lecture. So do you know Tim Berners-Lee, right? Yes. So this was the very first and famous quote from Tim Berners-Lee that he wrote on his first web server. So did you have a chance to look at the first web server in the world? No. Okay. So sorry?
Not server.
Okay. Okay. Yeah, I mean that's the website. Yeah. So so basically he wrote that in his first web server or web page, whatever you can call it, that World Wide Web is a wide area hypermedia information retrieval initiative aiming to give universal access to a large universe of documents. So as you can see, I highlighted it has 4 different crucial part. So wide area, so the network should be wide. It cannot be public or semi-public or private or whatever. So basically it's public, but it should be wide. Then the hypermedia information retrieval. So the information should be retrieved using hypermedia automatically. Basically the goal of web or internet is to retrieve the information, right? And he understood this like more than 25 years ago, or about around 30 years ago. And then it should be universally accessible. So all your documents that you are putting in a network or in internet should be universally accessible, and universe of documents. So if it's not like hundreds or thousands of documents, it should be billions or trillions of documents that we already have over the internet available. And this first sentence basically was the first sentence of the first web page that was deployed on the first web server in the history. So coming back to the web, so how web was, or where web was invented? It was invented in Switzerland in CERN lab, so basically European Organization for Nuclear Research. So this guy, Tim Berners-Lee, started his project. It was basically a non-profit small project in 1990s called World Wide Web. And after working around 1 year or maybe 11 months, I don't remember the exact, he invented a number of things with his colleagues. So you know this URL, right? So this is the first the web server or web page that was invented by Tim Berners for the first time. So during this 1 year time, what he invented the URI. Since you already know about REST, so you should know about what is URI. He also invented the HTTP, that is the very popular protocol for web, for the basically those are rules how two machines or two different web components should talk. Then she also invented HTML and a browser that was known as World Wide Web at that point, but now it's also known as Nexus. And he also invented a editor for HTML. Basically, that was rendered in the browser, and it was what you see is what you get. It was a simple HTML editor. So after inventing that web concept, it was basically in a very small scale. People did not know about web that much, and once it started to get popularity, people started to share their documents over the network. There was few million in the first year of the internet users, so it was growing very rapidly. And I think in 2 years' time, Roy Fielding and his team found that scalability is a big issue, and it's a major problem. If you don't handle that problem, your internet or your web will collapse, or people will not get any services, or they will not get the benefit of web. So to handle that scalability problem, basically, do you heard about this name? Did you heard about this name, Roy Fielding? So Roy Fielding was basically known as the father of REST or REST APIs. Or in other words, he proposed this 6 constraint. Given that if you follow this 6 constraint, that means your API or your application is RESTful. And if you miss any of those and you are claiming that maybe not the last one, code on demand. So if you are claiming those that I have this 6 constraint in my application, basically you don't have. So if you miss one of them, then you are basically kind of lying to your clients, or you are not using the REST fullness in full scale. So I guess you also know about this 6, or at least some part of it. Did you heard about those 6 constraints?
Not all 6.
Okay, so I will just give a very brief introduction. For those are like, some of them are very basic intuition, like client server. As we all know that in web applications or in any applications, we have this client server concept. So clients are basically who is consuming the service from the server, and sometimes clients and servers are developed individually, like independently, and they have different roles and responsibilities. And this was also to ensure that if client changes, it doesn't affect server. If server changes, it doesn't affect clients. But obviously, the clients who are using the services from the server will have to adapt at some point. But the goal is to have this separation of concern, so that one doesn't affect badly others. So we always have this concept client and server also in REST APIs. And then the uniform interface. So this is one of the most important aspect of web APIs, or we can call it REST APIs from now on. So this is one of the most important aspect of REST APIs. And this uniform interface tells you what you are accessing, how you are accessing them, and also how you are describing them. So in other words, so in REST, everything is a resource, right? It's a resource-based model or resource-based architecture. So since it's a resource-based architecture, it's like if you're thinking about SOAP services. Did you work on SOAP services before? No. So if you are thinking about SOAP services or WSDL services, those are based on only on service. So you cannot go below that level. But REST is basically based on resources. So everything is done or everything is designed is based on resources. So those resources should be identified well. So if you don't identify them well, you will have lots of problems. As a client, you will have accessing problems, manipulating problems, even like when you are working with resources in terms of sharing and displaying, you will have lots of problems. So if you don't clearly identify your resources. Then also manipulation of resources through representations. So once we are talking about resources, they also should be clearly represented using some well-defined form or structure. So at present, developers mostly use JSON, but XML can be also used. But there are not only XML or JSON, there are many more representations. So resources should be well represented in terms of standard representation. Then there should be also self-descriptive messages, like you should describe resources and its state, and basically these are the metadata. And finally, you should also use this Hatheos principle. So basically, you should rely highly on hypermedia, and hypermedia allows you basically to traverse across various states of resources. In other words, in your application, if you are following links, so if you are following one link, you find multiple other links, right? And those multiple links are related to this link that you clicked on. So if you follow then one of those links, it will give you other pages or other links. So this is basically the hypermedia concept in REST, and which is done mostly using links, and those are also like href tags in HTML. Those are similar to this concept. So this is also a very crucial concept in REST, this Hatheos principle, that you should rely on, you should convey the state of the resources through links to the clients. The third constraint, that is layered system. So we don't not only have clients and server. So between client and server, we might have many more other devices, like network devices or security devices, or even there are core benefits of REST, including, for example, caching or the general load balancing. So all these done are basically within the network between client and server. And if REST APIs, since REST APIs or web APIs were proposed to handle the scalability problem, and this response caching or load balancing, they all support scalability, and that's why layered system in general is a good constraint or common constraint for REST. And then the fourth one, cache. So cache or cacheability, this is also again crucial for scalability. So if you have a local cache of your data, you don't need to look for the same data to the server again. So in this way, server can support more other clients, and you can also have low latency or high availability using this caching principle. Then the stateless. So to be a REST, basically you want your server not to store user specific data. So every time users are making requests to the server, it should, or the client should, include related or relevant information for the server, so that he can also get the recent data or the data that he wants in particular. So there's another aspect of scalability. So if the web servers or server does not store lots of user data or state data, it will not use its memory like in a so basically it will not waste its memory, and if it doesn't waste its memory, it can provide or support more users as well. So this statelessness is another good constraint for REST. And finally, this is optional, that is code on demand. So many REST applications or many client developers don't implement this, or even the server developers, because basically what it does, it sends some code to the client. It sends some JavaScript code or some Flash or Java applets. But the problem with this constraint is server does not know if the client has this capability of executing those script, or if the client does have technologies to execute those scripts. So that's why Roy Fielding made this constraint as optional. So you can basically say that I have those 5 constraints implemented, but I don't have this, but still you can claim that your application is RESTful. So you got the idea, I guess now. Now let's come back to some common concept in REST. So I listed them, I guess 10 or 12 here, but there are many more. And if you are already introduced yourself to REST a little bit before this course, I think you should know already all of them. Do you have any questions or any concepts that you don't know? Because I don't want to go through all of them by one, but you have any new concepts that you don't know here, or anyone from online? So I guess then you know all the concepts. So I just want to give for an example, that's resource modeling. So do you know what's resource modeling? Like we have resources, but what does modeling mean? So it's basically similar concept to database design or object-oriented UML design. What you do, you have a bunch of resources, or you start with one resource, and then you try to find relevant or related resources and find the relationship between those resources, like how they are related to each other. So one resource can be part of another resource. One resource can be sub-hierarchical or semi-hierarchical to another resource, so in this way. And this resource modeling is also an important step before you actually start your development or implementation. Because if you don't have a clear model on your resources or about your resources, during the implementation you will make many mistakes. I will show some of those examples also later. Any other concept that might? So let me ask you a question then. So what is the difference between representation and resource state representation? So both are talking about representation. Any idea? So representation is basically, again, the very basic concept of REST. So every resource should have a representation. It can be in any media format or any media type. It can be in JSON, XML, text, whatever you want. But this resource state representation is basically the representation of a resource sent by the server that is the most recent. So it defines a specific state of a resource, and this one can be selected by the clients or server both, but this is only returned or sent by the servers. And then of course you know already about request message and response message. You also know about entity body, entity headers, caching, and the architectural constraint is all about what we are discussing until previous slide. So let's assume that you already know this concept, right?
Yep.
So now coming back to the core part of the course with this brief introduction on REST, identifier design with URIs. So what do you mean by identifier? That's the first basic question. So let me know if there is also any questions in the Slack, so that they can also participate in the discussion. So what is identifier, according to your background or knowledge?
Must be how to decide how we are going to structure our URIs.
That's design, not identifier.
Okay.
So what's your name?
Adam.
So basically your identifier is Adam. So every URI, it should have a unique and well-defined identifier. Because for example, Adam is very easy to pronounce, very easy to write. Even if you type, it's easy to type. So in this way, URIs, they should be designed with clearly and in other words, with quality design, so that you can use them easily. That's what I mentioned here. So basically, every resource should have a unique identifier so that we can address the resources. So these are the two examples of unique identifiers of these two URIs. So one is using a UUID, and another one is, so this basically this can be decoded later, and then another one is using 1, 2, 3, 4, 5 resources. Basically, as a design principle of REST APIs, all these resources. So Mona Lisa is a resource that is the hierarchy of Leonardo da Vinci, because Leonardo da Vinci draw many pictures or many images. So basically, he was an artist. So one of them is Mona Lisa, and then in Louvre Museum there are pictures or arts from many other artists. So Leonardo da Vinci was one of them. So this is also a part of this Louvre Museum. In Paris, they have many museums. So Louvre is one of them. So this is again part of Paris. And then, of course, France has many cities. Paris is one of them. So you can clearly see the hierarchical relationship between resources, right, or between nodes, in other words. So this is a very typical design or good design for URIs. And the format here is basically, do you know about this format before? No? So this is the very standard format defined in this this specification document, or this is the standard for designing the URI, RFC 3986. So it says the URI should be a scheme, and then slash, double slash, so colon, double slash, the authority, slash, the path, and then you can have different queries or parameters in your URI. So with this example, can you map different part of the URIs? So because for designing the URIs, knowing or organizing the URIs well is also one of the first steps. So from this URI, what is the scheme, what is the authority, what is the path, and what is the query or other parts?
Authority is Google, path is search, and query is client.
Query is client, you said, okay, and then path is?
Path is search.
Yeah.
And authority is google.com.
Yeah. And what about the scheme?
It's before www.
Yeah. So I think you got right, but not all of them. Basically, maybe this debatable. So the query should be always, yeah, from here until here. But some part, since this was an example from Google, some part of it is not part of the query. So for example, this part was not part of the query. This part was about representation, or how you represent your data, so or encoding representation. So for REST, up to here is the query, where you have the query parameters, what is the client, it can be Safari or Chrome or whatever, and then yeah, you were right. So this is the scheme. So this is basically the protocol, and then this is the authority, google.com, and then the path. So this is very common structure for the URIs. Now, coming to the design or identifier design, do you think it's a good design or bad design? This is a very simple. So think it as a very in a very simple way. the reason I marked them with green slash, obviously there is a reason. So maybe you can identify what is the reason that I marked them in green. I think I mentioned it also in the previous slide. So this is the first rule of designing identifier or designing URIs, that you need to always use forward slash to show your different resources that are in hierarchical order. And in addition to that, you always have to ensure that your resources are placed in a hierarchical manner. So what I mean by hierarchical manner is you can have many different types of shapes, right? Among those different types of shapes, you might have polygons. You can also have, like, polygons most means those has multiple lines or bars. So among those polygons, you can have polygons that has 4 lines, and among those, so quadrilateral, you can have squares, you can have whatever, rectangle. So if you can see clearly, there is a relationship between the resources, and the more inside you go, the more general it becomes, and more outside you go, the more specific it becomes. So this is very first rule of designing the URI, that forward slash separator must be used to indicate a hierarchical relationship, and your resource should be always in this way, because if you have a design that puts, for example, polygons before shape and square before quadrilateral, that means you have a very bad design, and the developers or users as a client who will be using your APIs will be totally confused or got lost. Then let's go back to second rule. So can you see the problems in these examples, or maybe in one of the examples? I think the examples also has the answer. So now we are moving into API design quality, or API design rules or practices that you must follow during your design. So what is the problem with the first URIs here? I think I already highlighted the problem in red. So the problem is, you never should add this forward slash at the end. So what's the reason?
Maybe indicates that's another level.
Yeah, so that's exactly the reason. So if you have a forward slash, client or the developers might think that there might be another resource coming up, but basically there is no resources. So in this case, you should simply have in this way. So never add a forward slash at the end of your URI, and that's, it says.
Question?
Yep.
Is it also, does that rule also apply if you have movies and then you have like separated by year and other child?
Yeah, but then if you have multiple childs, those multiple childs will also not end up with this forward slash. So basically the rule is that always you have to have a empty or single nodes, not a node by forward slash. So whatever, how many, it doesn't matter how many resources you have. I don't know why it's oh my. There was a pointer issue. Yeah, I think the pointer is not working. Okay, let's do it with hand. Yeah. So a trailing forward slash should not be included in the URI. Then moving to third rule. So from the example, what you can guess the rule can be. I already marked in green though to make it easier to understand. yeah, you don't have to use spaces, but this rule is about not about spaces, it's about dashes. So the rule is you should not write complex words or compound words. So instead of writing mark masse together, add a dash. Instead of writing this is my first post, use dash in between each word, and this also makes the URIs readable and or understandable easily. But if you use space, that might create another problem, because it might break the URIs when clients are using them or copy pasting them or whatever. So this is the third rule, and even they seem like very basic rule, but for the client developers, those are really critical to use them properly. So hyphens should be used to improve the readability of URIs. Then I think this is the most important one. So what do you think is the problem in this URI? And this is also a very common problem that are found in reality. So what's the problem with this URI?
That they are using underscore.
Yes, exactly. They are using underscore, but it is a link, so that you basically when you click the link, it will follow the link, but they used underscore since it was underlined, because for example some document or Word document, they put underline if you are using hyperlinks, but since it's underlined, you don't see the underscores. And this is the very basic or one of the very common problems by the developers. They use underscores in URIs, and you never should use underscores in URI, and that's the problem because of using underscore, because it has the underscore but you don't see it.
You have a question in Slack.
What's the question?
Why not use camel case instead of hyphens?
Yeah, that is another solution, and as far as I remember, there was no specific, no defined rule for camel case, but instead of hyphens you can also use camel case, but not basically making them like all small case then mixing up. So if you write here mark and then using camel case masse, then it's also fine. But I think there is a one rule, I will come back to that point regarding this camel case thing, or regarding this uppercase thing. So this is another rule: underscore should never be used in URIs. So until now, what we are talking about, so this was rule 4, and maybe there are a few more rules about structure or the design in terms of structure of the URI, not in terms of meaning. So basically until now there was no meaning related to these rules. So there are some rules in future that I will discuss also today. Those are more about meanings also, or semantics. So this is all about syntax. I don't know why my pointer is not working sometimes. Okay. Yeah, so we were here. And then, yeah, maybe this will answer to your question. So what is the problem with these 3 URIs? The first one looks okay. Second one does not okay. Third one also does not look okay. So basically, in the second case, as you can see, even though it doesn't matter for the browsing purpose or for visiting this URI, for the client it matters, for the client developers, because this part was in all small case and this part was all in higher uppercase. So this is also a bad example of design. So basically what you need to do, you need to use uppercase and lowercase consistently. and this was not a consistent example of uppercase and lowercase. What you suggest, yeah, you can use camel case, but at least not for the main the like scheme and the authority part, but maybe for the resources part you can use camel case. So that it says that lowercase letters should be preferred in URI paths. So if it's possible, always try to follow number 1. If it's problem for your naming your resources, maybe you can try number 3, but using camel cases, but never try number 2. And this is precisely defined in this standard, and basically standards are defined so that you can follow them. Now, what's the problem with this representation, you think, or this URI design? I did not mark it, yeah, also because of some reasons, so that I don't show the results or answer. So this is another very basic design principle for REST URIs. Never include file extensions in the URI. This file extension, if you use them, that means you are not using the response body for describing your metadata or for describing your resources. But if you are using, for example, this URI against a get method or against a put method, and you have already a body that has a JSON body, and you are also putting here this file name as fall.json, basically you are duplicating information, or you are abusing the REST URI design guidelines. So never use not only JSON, for any other file types, never use in your URI design. So all those file types or media types, they should be reflected in your metadata or in your request or response body. That it says that file extensions should not be included in the URIs. This is also a very basic rule. So rule number 7, consistent subdomain names should be used for your APIs. So this is your subdomain API dot, and then this is your service provider soccer.restapi.org. So if you have multiple resource or multiple endpoint, you should design your subdomains consistently. So this is what I mean by subdomain is you might have, for example, I have a URI in the next example. So for example, this api.soccer.restapi.org is the main API for the client developers or the public to consume the services. But the next rule, it says that for the next rule in this example, as you can see, for the similar example or URI, we have developer here instead of API. So for developers, you should always have one endpoint. For consuming the services, you should always have one endpoint like api.soccer.restapi.org. So in this way, you should be consistent. For different goal or different purpose, you should design your APIs. And the following rules, that is rules 8, it says again, consistent subdomain should be preferred for your client developer. So when you are developing a API for clients, it should be always in this way, either dev.soccer.something or developer.soccer or something. And it's also important for the client developers to easily identify their URIs, because if the client developers using this API, it will basically mislead them. So always design your URIs with consistent subdomain. Now coming back to resource modeling. So until now we were talking about basically URI design or URI design rules, and now we are talking about resources, and obviously URIs are composed of resources. And I also mentioned, I think in the concept slide, what is resource model. So resource model is basically where you design your URI considering that each node of the URI is a resource and they are part of a resource model. So, for example, leagues / Seattle / teams / Trebuchet is a resource model, and it is a resource model for Trebuchet. So, you cannot, or you can never access directly to this resource without accessing your other resources that are more at the higher level. And defining this kind of hierarchy or this kind of relationships is basically goal of your resource modeling, or this step is known as resource model. And as I also mentioned, this is similar to database design or database schema, because also in your database you define different data and how they are related. So, you design your tables. So, in the REST concept, those are seen as a tabular relationship. So, you have a table called leagues, which has subtables called Seattle, so different cities, which has subtables called teams, so different teams. Under the subtable you have a particular team. So, while we are talking about resource modeling, there are also various types of resources. So, do you know any of those types, like document, collection, store, and controller? I guess you know document or maybe collection. So, do you know about controller and store? No? So, controller is also kind of new, but very useful concept for designing RESTful APIs, and you will see why. But before that, let me introduce briefly these 4 types of so they are known as resources archetypes or archetypes, whatever you know, say it. So, the first one is document, and it's a very classical example of REST resource. So, a document can be a single JSON file, it can be a database record, it can be a name of a player, it can be a news or whatever. So, a document resource is anything that is a single item or single resource or single object. So, examples here. So, for example, Mike is a player of this Trebuchet team that is a league in Seattle. So, this Mike is a single resource or single object. Again, Trebuchet is a team object that is a team in Seattle league, and then Seattle is a single city or league team that is among the various leagues in USA, let us say. Then collection. So, then there is a difference between collection and store. So, collection is basically a server managed resource. Client cannot delete the collection. It can add items to the collection, but again the server or the collection resource should permit them. And store is basically a client managed resource. So, they are most often stored in on the client side, or client basically have full control over those, but client does not have full control over the collection. For example, if I am a API developer or API user, I can add new players to this resource if the server allows, but I cannot delete this resource. But as a client developer, if I want to add some information about these users with this ID. So, we have a number of users and one of them is 1234 ID, and we want to add some information about this user to the database, we can do that. So, we have the full control over the store. And another difference between them is every time you add a resource to the collection, so let us say players / Adam. So, we are creating a new resource called Adam. We can do that, but as a client developer, we cannot create a new resource. For example, users, then his ID, then favorites. So, this is one of the guy I think who plays Formula 1 or something, and then we cannot add new resource here. So what we can do as a client developers, we simply parameterize this user ID, and then for the same user or different users we can add different information. And then finally the controller. So the goal of having controller is, we know there are basic HTTP methods, right? What are those methods? Get, post, put, and delete. Let's say we have these 4, and we want to do something more, and REST standard methods doesn't have them. Then the controller comes into the picture and is useful because it's basically a verb or an action basically that do something that beyond the REST APIs or REST design allow you, or basically HTTP allows you. For example, we want to resend a notification or message or alert, but this resend takes the input, for example this alert ID or alert message ID, and it also produces the output. So the users who will receive the alert might read or not. So if he reads that, then a confirmation will be sent. So this activity, sending a alert and receiving a confirmation, it does not supported. It's not supported by any HTTP methods, right? So what we can do, we can use this post method. So post method is always used for controller. So for controller, you cannot use any other method than post. So using this post method, you can define a function or a procedural function that will take this one as the input and will produce some output. So that's the controller is used for in REST API design, and they also are used in today's APIs like Facebook, YouTube, or whatever. They use highly these controllers. So these are the 4 archetype device design for, or archetype types for REST resources. And now we will go to some rules related to those design, or some related to their resource design. So one of the first rule is a singular noun should be always used for document names. So as we mentioned earlier, the document is a single object or single instance or single data or a single file. So that's why the document name should be always singular. Sorry. So for example, Claudio is a player. So this is a plural resource, and after this plural resource, so there are multiple resources. So Claudio is one of them. So now if we add a method called get and then call this URI, it will give information about Claudio. So if I want to ask you, then now, so this is a document. So what is this players resource? I think I also mentioned in the previous slide. Yeah, this is a collection because this is a server managed resource. I think there is another rule regarding collection after. Yeah, here. So a collection should name should be always plural. It cannot be singular. So if you put a singular name for the collection, it's very easy for the client developers to get, to make mistake or to get lost. And we don't want as an API provider our client developers to make mistakes with our API. So the first basic rule is the document name should be always singular. The collection name should be always plural, as well as for the store names. So here is the playlist by this website or by this artist. So this playlist is a store, and you can add information about songs in this playlist. So it can have other parameterized resources, but this playlist also is managed by the clients. So when we add a resource, let's say /by song ID, we should get a particular song about from this playlist. So similar to collection, the store names should be always also plural. Then about the controller. So we always need to use verb or verb phrase for controller. So as I mentioned earlier, that we cannot do such things using standard HTTP methods. That's why we have to add this kind of actions at the end of URIs as a resource. But when you find that there is a verb like this at the end of the URIs, that means by default this is a controller that's doing something backend, and for that one by default you need to use post method always. So these are the 4 examples of controller names or controller URIs. For example, this is doing the registration. Registration does not have any HTTP verbs, or the HTTP methods does not have any support for registration. For example, this is a deduplication, so it's removing all the duplications for this ID from the list. So there is also no HTTP methods for doing this kind of removing the duplications. There is also no re-index support for HTTP methods, or if you want to run a test suite over the browser, you can also do like writing this kind of methods or functions where you provide the input and output for the test case, for example. So these are very common uses for controllers, and for today's modern test tools, this is also one common use where you remotely run test cases using test data. So in terms of URI path design, there is another rule that says you can pass variables through your URI, and this is also very common or known approach for URI design. Let's say you want to parameterize your URI design where you have 1, 2, 3 variables, and when you are sending the request to the server as a client, you can substitute those values by parameters. And this is a alternative approach also by using the question mark. So when you are using question mark, basically you can say that league ID is the Seattle, then comma team ID is Trebuchet, and comma player ID is 21. So both are alternative approaches, and you can use both of them. And alternatively, you can also use UUIDs. So if you are parameterizing a game ID at runtime, you can replace the game ID by this UUID, where in the next steps this UUID or the value will be decoded using this UUID. So this is 2 examples of again also URI path design. So now coming back to the URI design or path design. So what do you think is the problem? So this is probably the last question before we have a short break. So what is the problem with these 4 URIs? So in the first case, you are deleting a user with the ID 1234. In the second case, you are also deleting this ID, this user, but instead of passing a parameter, you are simply saying that, okay, I want to delete this user. In the third case, we are also deleting. In the fourth case, we are also deleting, but then what's the difference between them and what's the problem with them? It can be a tough question, but the answer is also in the URIs itself. And if you think both the method and the URI, maybe you can find the answer. So look at the URI methods and the URI as a pair. I don't find the clue. For some of the method URI pair, do they contradict or do they duplicate? So for the first, second, and fourth, as you can see, they are contradicting, and in the third case they are duplicating. So you are using the get method. So why we use the get method? To get a state resource state, right, or resource representation. So we are using get method, but we are saying here the controller or the resource that delete user. So this is contradicting, right? So here we are saying retrieve, but here we are saying delete. You cannot do that in the same time, or you cannot define or design URIs in this way. In the second case also, you are retrieving using get, but you are saying that delete this user. So this is also contradicting. In the third case, you are duplicating. You are deleting a resource, that's fine, but then you are designing your URI by duplicating the terms or words. In the third case, this is also a problem, because you are saying that you will create a new resource by using post, but basically you are using a controller to delete this user. So this is also contradicting. And the rule says, so what's the good example? The good example is like simply delete, then call this URI. So it will delete this URI, this users with 1, 2, 3, 4 ID. So the rule says CRUD function names never should be used in URIs. So when you are designing the URIs, never use delete or create or update or read, or in general any verbs in your URI. So since we are talking about all about resources, and resources should be always noun, you cannot imply a resource by a verb, or you cannot design a resource as a verb basically. It could be possible, for example this one, if you think that delete is a controller, but usually for HTTP methods you already have a verb delete, so you should not also duplicate delete and then delete. So for that one, if you want to do, then what you can do, post user / 1, 2, 3, 4. Let's say you, instead of deleting, you want to move these users from this database or from this resource to another resource. Maybe you can use, for example, move here, then it should be fine. But this delete function is already available in the HTTP methods function, so you should not duplicate these cases. So you got the idea, right? Then query design. So we already talked about query, and also it is similar to the typical URI design scheme. So you have a scheme, you have authority, you have path, and then the question mark, and then the query. So these are the two examples. So you want to send a SMS. So this is again a controller, and then you basically simply put the parameters or the part of the query. Rule 15, it says you can use parameters or query to filter your collections or stores or your resources. So simply put get users and get all the users whose role is admin. So this is also possible. I mean, using query or parameters are possible for filtering your collections. Then also you can use your query part of the URI to paginate or to cut down your results. So let's say you are finding the users with all the role with the role of admin, and then you want to show like 20 for each page, and your page will start from the index of 50. So if you found 60 or 100 users with role admin, you show from the 50 and you show only 25 or first 25 starting from 50. So in this way basically you can paginate the collection or store results. So now I think, if you do you have any question before we take a break? So let's take a what's the time?
2:20.
Let's take a 5 minutes break then.
Yeah.
So until now we were talking about identifier design. So in terms of basically URI, in other words, URI design. And as a client developers, we are using those URI. And while we are using those URI, we are interacting with the servers, right, with the services. So those interaction design is also important for our client developers and also for the service servers, so that our interactions design should be also well defined and it should be meaningful.
You got a question in Slack there. What are RESTful APIs used for? Could you give an example?
So that's a good question, but then if you know about what are RESTful APIs, so what was the name? Mark Mathur. So do you know what's RESTful APIs, or when we call APIs RESTful? I guess
There is a bit of delay in the recording.
yeah. Yeah, but I wanted to know or ask him, does he know the definition of RESTful APIs, or when APIs become RESTful? So, okay, without making delay, let me go back to his question.
Oh, he responded.
I have used it, but I'm not sure exactly how they are used in real life. Okay. So basically, an API can be a RESTful or not. So when are we calling it RESTful, and when we are not calling it RESTful? So that's the question I think he wanted to know. So if you remember those 6 constraints, so if you are following them in your APIs, or when you are designing your APIs or implementing your APIs, if you apply those 5 or 6 constraints, that means by default or by definition your API is RESTful. That means your API should provide, so in general it should be client-server concept. It should be designed in the layered architecture in mind, so there should be some caching or load balancing in between, for example, or any other security measures. It should have cacheability support. It should be stateless. That's the most important part for RESTful APIs, for APIs to be RESTful. And then what else? Did I miss anything? And then it should be also provide code on demand benefits if possible, because that's optional. So did you get the answer to your questions, Mark Mathur? So any APIs, it can be designed using any technologies. If they adhere to those 6 constraints, we call them RESTful APIs. So let's go back to the slides now. So what is interaction? Interaction is basically the communication between client and the server. In other words, when clients wants to access the resources provided by the server. And this is also a very good property of REST APIs, is that by default it provides or supports all the HTTP related protocols, methods, design in terms of headers or bodies. So
They can see the slides on the
mixed, okay. Sorry, yeah. What I was talking about, about this interaction design, and in particular how they are related to with HTTP. As by default, as I mentioned, I was mentioning, it supports and it basically copies the REST APIs, all the HTTP methods, all the response code, all the message design, so in terms of body and in terms of headers. And while we are talking about response code, see, these response codes are basically one of the crucial way of having meaningful interaction between client and servers. So by different codes, you indicate how well or how bad or how good your communication was or how successful it was in terms of code. But in terms of methods, so how many REST methods or HTTP methods you used or know? 5, 4, 3, 6. So 3. So which 3 you worked with? Get. Okay. Yeah. There are basically 9. So maybe as a developer we don't rely on them, or not all of them, but we should rely or try to use all of them, because in the first place, let's say HTTP 1.1.0, there was only 4 methods, and then with the time they standardized more methods, and sometimes they are really useful. For example, the most useful one of the most useful method is head. So it gives a metadata or some information about a resource without bringing in the resource itself. So it just gives the metadata. So if you want to know something like what media types or what representations this resource have, if you put simply, if you make this call with a head and then the URI, it gives you many different information without bringing the resource, actual resource. And then of course the put and delete are common. Post, connect, if you want to establish a connection between the resource, like if you want to see that if a resource exists or not, you can use this method. Then options, for example, for a resource, what methods you can apply on. For example, a player, I can either get information on the player, I can add a player, I can delete a player. So using these options on a player resource will give you these 3 methods or these 3 actions that you can do. Then also you can trace back a resource, and finally this is one of the very new method called patch. Basically you can do some partial modifications or apply some partial changes on resources by using patch method, but not by changing the whole resources, but maybe some attribute of it. And you can mention which attribute we want to modify or change. So the rule 17 says, so as some of you was mentioning that you used get, put, and what else? Post. So this is one very common problem, not with you, but many developers. They try to use only get and post for doing everything, including deleting, including updating, including getting some metadata or whatever. And if you do that, basically you are abusing HTTP. You are claiming that you are RESTful, but you are not RESTful in that sense, because your resource is not uniform. There was a constraint, if you remember, uniform resource, right? I don't remember also. So there was a constraint that uniform interface. So your interface should be uniform. And if you are only using get and post for doing everything, you are not using all those 9 or maybe most of the methods that you can use, basically your interface is not uniform. And it not only misrepresents REST and HTTP, but it also misrepresents or undermine the HTTP protocol as itself, because all those 9 methods, they are part of HTTP, and REST is based on HTTP. And if you don't use properly the HTTP, that means you are not properly using the REST. So there is an example. So that was the rule 17, that you have to use all possible methods to access or deal with your resources, not only get and post. And the rule 18, it says get method must be used to retrieve a representation of a resource. So this is also similar to rule 17, because most often developers try to use get for other purposes. And if you are twisting this get method and trying to do other things with this get method, that means sometimes you need a body for the get request, right? But the rule, as a general rule, you can never have a body for get request. So if you have a body for get request, that means, I mean request body, that means you are misusing a get. For example, this is a simple example, like you are using this curl command on this URI to get a greeting message. So if you are not giving any method, by default it's get, but it doesn't have any body, or it should not have any body. So that's the rule. It says that it may only contain headers but no body. That's rule 18. Rule 19 says head should be used to retrieve response headers. Again, it should not have any body, and it's also useful for getting the metadata for the resource. So again, if you simply use curl and then this is the method, so you can either use any of the method, and then the URI, you are basically providing no body here, and it will give or return a metadata, some metadata regarding greeting resource. I think this part will be a little bit quicker because we finished already most of the part before the break. Rule 20 says put must be used to update mutable resources. So there are two important things that to note, like you can use put only on mutable resources, and put must be used always to update. So you cannot use put to create a resource, and you cannot use put on unmutable resources. But exception to get and header or head function, put message may or may not include a body. So post is also similar to put, but post is only for creating new resources in a collection. It can also have a body similar to put, but that's the only difference between post and put. Like post is when you are putting for example, a new message for the students on the bulletin board, because there was no message relating to that event or relating to that information. But put can be you already have a message, but you are putting a new message on that existing message. That's the difference between post and put. An example can be you are creating a player under this player's resource, and the body of that new resource will be provided. The details of that new provided resource will be provided in the body. And that was rule 21. The rule 22 says, I think I also mentioned it in the first part of the lecture. So post must be used to execute controller. So we already know what is controller. It's one of the archetype of resources. When you cannot do something with existing HTTP methods, you use a verb or verb phrase to do something, and for that you always need to use post. You cannot use put or other methods, or get or delete or whatever. One of the examples is shown here. So resend, maybe if you are doing only sending only some alerts, maybe you can use get or something, but when you are using this resend verb phrase, that means it's doing more than a get, and in that case you have to use a post method, and also similarly you can provide a body if you want. So, and one important thing is, when you are executing controllers using post, basically those are always unsafe and non-idempotent. So do you know what those mean? This is another I would say important concept, or maybe very important concept if you are designing REST APIs or REST URIs or RESTful resources, is that to think about, by using this method on some resources, are you changing the state, or are you modifying the resource, or are you changing the resource or not? For example, I can use put method to update something, right? To update, for example, information of the users or players. So that put method is unsafe because it's modifying the information of that player. So this is the safe versus unsafe. And what is idempotent versus not idempotent? Basically, for example, I am using a get method on a resource, let's say on a blog post or on a news. So even if I call the get method on the same blog post 100 times, every time I will receive the same input, right? Sorry, same response. But if I am, for example, calling a delete method on a blog post, first time I will get, okay, the blog was deleted, but the second time, can I delete the blog again, or the blog post, because I already deleted once. So the second time the output will not be the same. So that's why the get method is idempotent. So if you call the same method on the same resource multiple times, you will always get the same results. But if for one method, when you apply it on a resource and you get a different result for different times, then it's not idempotent, it's called non-idempotent. And then it comes to this table. So out of those 9, I think I showed here 6, 7. So out which I missed, I think trace and another one method. So those methods are not basically doing anything on the resources. Only these 7 methods are doing or performing something on the resources. And here I am showing which methods are changing the state of the resource, and for which method every time I am calling them on a resource, are they changing the output or not. For example, options. It's idempotent. Yes means every time I call options on a resource, I will get the same response. And every time I apply options on a resource, it will not change the resource. So it is safe. But for put or for post, for example, the thing I mentioned, every time I call post method on a resource, in the first case it will update. In the second case, it might also update. So since this is used for updating or creating the resource, it's non-idempotent and it's not safe. So it's changed the state of the resources. But for the patch, for example, it's completely opposite of gate or options, because both of them are safe and both of them don't change the state. But for patch, both of them, so basically it's not safe, because since it's partially modifying the resources, and also every time we call patch on a resource, every time it will change, it will have different output, because we are trying to change something. So this table is also important for remembering safely which method you want to use. So sometimes you want to use put, but by mistake you use post. That means you are considering your resources or responses different every time you are applying on some resource these two methods. So as you can see, they are they are not similar on the resources every time you call them. So you have to be careful choosing the right method for the right goal. So in terms of interaction design, so do you know about response code or HTTP codes? So there are many different HTTP codes, and using those code properly is also important for meaningful communications between client and server. So one of the code is 404. It says delete method must be used to remove resource from its parent. So once you delete a resource, since it no longer be there, and next time when you try to delete it, it should basically show this this method or this code that it's not there or not found because you already deleted it. And this is another rule using this delete method. And because all these codes or messages are also designed by the developers, mostly server-side developers, they should also carefully choose those messages, because based on those messages, client will take their appropriate action. And if you have the wrong messages here, client will be also mislead or misunderstand the state of the resource. So in terms of code, I was talking about, so there can be 1 series, 2 series, 3 series, 4 series, and 5 series of codes. I think there is about maybe 50 or 60 even more codes. I don't remember all of them, and nobody remembers all of them. But in general, the 1x series, like 101, 102, they all talk about communication protocol or about HTTP, if the communication was good or not when you are thinking about from the HTTP perspective. And then there is 2 series when it's talking about the actions. So whatever the actions user or client did, if it were successfully done or not. Then the 3 series is basically about redirection. So it's about basically server side, like 2 series is about client side actions, but 3 series is about server side. So if there are resources that were moved to new location, or the URI has changed, or it was removed permanently, so then the server can send different types of messages of the 3 series to client to tell them that this resource, for example, moved to this new URI. So you have to call, or you have to make a request using this new URI. And then there is 4x series, like all kinds of client error. It can be a bad parameter, it can be a bad request, or not well-formed document, not well-formed body, and so on. But then there is also 5 series, that is server error. If server is down, or server is currently out of service and in maintenance, and all these things. And there are many numbers, of course, for these different numbers for this client and server errors. And the goal of this introducing of these numbers or of these codes is basically, again, as I said, like if you don't give the proper code or proper message, client will be easily or very frequently misled or misunderstood the actions or the communications. So it's important for proper code and proper message by the server to the clients. So there is one example or the format how your interaction or how your status message should be formed. So the first of all, the HTTP version, so http/1.1, and then the space status code. So we have a space here, and this code can be of any of the series. And then space reason phase. So basically this is the reason phase or message, and it can be any message corresponding to the code and then the new line. So this is the very, I think it's a little bit different than 1.1, 1.0, but this is the recent format for sending the status to the clients. So based on the status message, client will not understand what's the problem or what's going on in the server side. So rule 24, it's about, so basically these are the client action related status messages or status code. So one of the most common that developers use is 200, but the problem and or why this rule is important, because regardless of the type of success or regardless of the type of action, developers always try to use 200s, no matter what. 200 okay, 200 okay. So they just try to convey a message that is not meaningful enough for the developers or for the clients. So you should, the rule says you should use different message or code dedicated to different goals or objectives. So if the resource was created, don't say just okay 200, say 201 created. If the request was accepted, don't say that 200 okay, say 202 accepted. So in this way, to try to be more specific for the status code or for the interaction design. Then rule 25, it was about server side. So it's about if the resources are moved to somewhere, if you need further information to get a resource or to modify a resource, or if the server is under maintenance and you are temporarily redirecting to another server, let's say. So in this way, you should also guide the users to proper resource or proper server directory, because if you don't, for example, redirect a client that is asking for a request, for asking for a resource, basically you are not providing the service to the client. Rather, if you are temporarily putting your server in maintenance and you want your clients to automatically get the new location of the new resources, you simply say that okay 300 with this message and provide the new URI of the resource. So these are also examples of meaningful communication between servers and clients. These are the client side errors. So these two, as you can see, are marked in bold because developers blindly use only these two for all kinds of problems, but for sure there are very specific uses of specific code, and you should use those code as applicable. Don't just use 400 or 404 as a general solution. And also from the server side, there are I listed basically some of them, but there are many others, both for the client and server. So servers most often use only 500 to show general server errors, but client also need to know what are the very specific problems or what are the specific cause that he did not get a resource. So it can be many things. It can be, for example, syntax error in your parameter in the URI, or it can be a missing argument or a wrong argument. So try to be specific by saying that it's 501. It can be a bad sequence of command. So if there are multiple sequence in terms of HTTP method or in terms of resource design in URI, and if you randomly or misplace resources in your request, it can say that okay, your resources were mentioned, but they were not in a good sequence. So you can specifically say that it was 503. So in this way, there can be multiple others code. And why this code are important, as I say also, like this proper information can give both the clients and the server, or they can help them to follow or to get the proper resources they are looking for. So to wrap up the session, if there are any no other question. Okay. There was no other question in the Slack. So we want to wrap up the session and what we have learned so far today. The first thing that we learned that quality URI design in terms of parameters, in terms of naming, in terms of syntax is crucial for understanding the URI, and it's more important for the client developers. And that is between rule 1 and 8. Rule 9 to 16, it says about proper use of singular terms and plural terms, nouns and verbs while you are naming the resources. So we found there are 4 types of resources: controller, store, document, and collection. So you have to be careful how you name them in terms of singular, plural, and noun and verb. That's about rule between 9 and 16. And rule 17 to 24, it says the various uses of HTTP methods, because you cannot use post, let's say for example for deleting a resource, but if you are using a controller you have to always use post. For example, you cannot always use get and post to do everything you want. There are many other methods, so you have to apply those methods that are semantically correct. And also this rule says that you cannot use verbs, like if you are deleting a resource, you cannot use this delete word in your URI design. And then finally the communication between client and server. So there are various semantics of various HTTP codes or response code, in other words. So you have to use all of them if possible to make the communication between clients and server more meaningful and correct. And that's the rule between 24 and 27. So the goal of introducing all those 27 rules is so that when you are doing your assignment, how much or to what extent you can apply this rule to your API design or to your implementation, and that will be also assessed. And this was about URI design and interaction design. I think in the next slide we will talk about metadata design, and I don't remember all the content, but it's on Wednesday and at the same time. So before closing the session, you have any questions about assignment, about the lectures, or anything? And if you don't have any other questions, I hope. So anyone online have any questions?
I have a question about using the HTTP methods. Do you have to have support for every method when you're building a?
Not necessarily. It depends how you build your resource model first,
Yeah.
and what resources you have. So once you know what resources you have, and then you know what are the actions you want to perform on them, right?
Yeah.
And then based on those you can select the methods. But if you don't need all 9 of them, maybe you need only 2 or 3 of them, you can just go to them.
But I don't think we're familiar with options or even head.
But those are simple methods.
Yeah.
But then the question is, if you are not leveraging at least the basic 4 HTTP methods, your interface is not uniform. So that interface being uniform is also constraint for REST APIs. So that's the thing you have to remember.
Is it common using delete operations in APIs? Because when I have explored APIs, I have only seen get methods. I mean, get this data, not me being able to manipulate the data coming out from the API.
Yeah.
That's because I'm a client. And
yeah.
I shouldn't have the
So it depends basically what resources you are handling. If your resources, again, like I think collection and store. So if you're handling collection, you cannot, you might not be allowed to delete the resources. But if you are handling the store, again depends on the resource type, but if you find examples where resource developers are blindly using only get and put or get or and post, that means they are avoiding. So that's another rule, like don't use, I think one of the first rule, don't use get and post for everything. So developers are doing that to save time or basically to make it more general or easy for them to develop.
But a complete REST API or a RESTful API does not need to implement features of deleting or updating.
No, not necessarily.
No.
Not necessarily, but as a client, you are designing the API, but if your clients want to delete something or whatever, then basically you have to provide that. But again, what I said to him, first you identify the resources, and then you want to identify what are the actions you want to make those resources on by your clients. So if there is a possibility that they might delete resources, so then you have to provide this delete. But if you don't want them to delete, then I mean you can also ignore that one. So if nobody has questions, then maybe we can. So we can wrap up the session and see you on Wednesday.
Yes. Thank you.